Hello students! A circuit that includes a DC power supply is called DC circuit, while a circuit that includes an AC power supply is called AC circuit. In Chapter 2, we will first learn about the basic analysis method of DC circuit. Basic analysis method of DC circuit, which includes resistor connections, equivalent transformation of power supply, Kirchhoff law, superposition theorem, and so on. Today, we'll start with the analysis of resistor connections. Resistance is the most common component in the circuit. Several resistance elements connect one after another in sequence and flow through the same current, which is called series connection of resistors. As shown in the figure, two resistors R sub 1 and R sub 2 are connected in series. Externally, they can be equivalent to a resistor R, because U equals U1 plus U2 equals I bracket R1 plus R2 bracket equals IR. Therefore, R equals R1 plus R2. If the resistance of two series resistors satisfy R1 much more than R2, then R approximately equals to R1. By expanding the number of series resistors, it can be concluded that equivalent resistance is R equals R1 plus R2 plus series plus Rn equals sigma Rn. The partial pressure formula states that the voltage drop of each section is proportional to the resistance. U sub 1 equals bracket R sub 1 over R bracket U. U sub 2 equals bracket R sub 2 over R bracket U. So we can infer that the ratio of U1 to U2 equals the ratio of R1 to R2 is proportional, and the ratio of P1 to P2 equals the ratio of R1 to R2 is also proportional. In summary, we have found that resistors in series act as voltage dividers and limit the current. For example, as shown in the figure, if a full-scale deflection current is 50 microamps and the header resistance Rg is 2 kilo-ohm, how much additional resistance Rf should be connected in series in order to create a DC voltmeter with a 100 V range? According to the analysis of the meaning of the question, because the current that the meter can pass is certain, the full-scale meter voltage based on Ohm's law is Ug equals Rgi equals 2 multiple 50 equals 0.1 V. In order to make a 100 V DC voltmeter, the necessary additional resistance voltage should be Uf equals 100 minus 0.1 equals 99.9 V, and thus Rf equals Uf over I equals 99.9 over 50 microampere equals 1998 ohm. Of course, there are various methods of analysis. According to the partial pressure formula, we can get the same result. As shown in the figure, several resistors are connected to the same pair of nodes. When connected in parallel, each resistor bears the same voltage. It is called parallel connection. The resistor R1, R2, series Rn are connected in parallel, which means they're effectively equivalent to a total resistance when connected to an external circuit. The total current in the circuit I is divided among all the parallel branches. We express it as I equals I sub 1 plus I sub 2 plus series plus I sub n. Each current on the right side of the equation is represented by Ohm's law as I equals U over R. By substituting and rearranging, we can obtain the equation 1 over R equals 1 over R sub 1 plus 1 over R sub 2 plus series 1 over R sub n. This equation represents the current magnitude obtained in each parallel branch. For example, when R1 and R2 are connected in parallel, The current relationship obtained by shunt is the ratio of I1 to I2 equals the ratio of R1 to R2, which means that the current distribution is inversely proportional to resistance. In terms of power, the ratio of power is also inversely proportional to resistance. We found that the parallel connection of resistors play a shunt role, allowing the current to be divided. In conventional circuits, in addition to parallel and series resistance, there are sometimes instances where a combination of series and parallel connections occurs, referred to as a hybrid connection or mixed connection. Part of the circuit as shown in the figure below, observing from points A and B, with R1 and R3, as well as R4 and R5, all connected between the same 2 points. Therefore, they are in a parallel relationship. After these 4 resistors are connected in parallel in pairs, there are no more nodes in the circuit except for points A and B. So, their equivalent resistance is in series with R1 and R6, which is expressed as RAB equals R1 plus R6 plus bracket R2 over R3 bracket plus bracket R4 over R5 bracket. The key to calculating the equivalent resistance of a resistance series parallel circuit lies in correctly identifying the circuit's connection points and then simplifying the resistance between the 2 nodes through series and parallel calculations. Finally, connecting the simplified equivalent resistance in series allows the determination of the overall equivalent resistance. Through the above study, we know that resistance is an energy-consuming element. That is, the consumed electric energy is changed into heat energy. For series resistance, voltage is proportional to resistance. In other words, the greater the resistance, the higher the voltage, while the smaller the resistance, the lower the voltage. When 2 resistors are connected in parallel, the total current is the sum of 2 branch currents, and the distribution of current is inversely proportional to the resistance. As for more knowledge, see you next time!